The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of Hawaii Tracker, bringing you guys another volcano update from Hawaii Tracker here. So Hawaiian Volcano Tracker plus Samoa this week a little bit, as we've been doing the last few weeks. Today is Thursday, September the 8th, 2022, and it's been pretty much business as usual on Kilauea, Maunaloa, and Samoa, really all of them kind of settling into a little pattern here. So we'll detail all that for you guys, as usual, with our webcams, a little bit of the highlight of lava viewing from 2 pineapples, and all of that. Dane, what you got to share with us this evening?
Yeah, I mean, it looks pretty much like a standard week on Kilauea. This past 6 months have been pretty consistent. We had that one phase a while ago, seems so distant at this point in the eruption, where we had the pauses and then unpauses every few days, but now it's just been pretty steady for the past few months, and it seems like that September 29th date, the 1-year anniversary, that seems like a lock right here. But you know, we'll see. Interested to see the new update, and I know you made something special for us with the maps that USGS has produced, so that'll be interesting to go through. And of course, we'll touch on Samoa. The earthquake activity out there, I mean, nobody's really covering it, so we'll talk about it, except for, of course, USGS, who's gone out there, HVO, Hawaii Volcano Observatory, tasked with going out there and kind of figuring out what's going on and monitoring it, part of their scope of operations. So they're out and on it, and we're going to cover it. So pass it to you, Phil. You go through the first part of this.
Yeah, it's really been, I was trying to look back and see how long it's been since we had one of those little pauses, and because it was really pausing, and then after the pause, it would kind of come back and burst out, and you'd see lava coming out of the west vent in some direction, or the pond overflowing, and it hasn't been so much of that. It's really been ooze-up flows and a lake circulating, and ooze-up flows and a lake circulating, right? There was a kind of in-between phase a little bit when we saw a few of those flows come through the crust in the middle and on the eastern backside. But really,
right.
When I was looking at the dates, I think that goes back to, you know, April or even March, right? So it's getting about 6 month-ish of it being in a fairly regular pattern now.
Yeah, I remember we were talking, even at one point it was getting so drastic, we were talking about how this could have been any pause could be the last pause of the eruption, and the eruption just ends. And it wasn't just us talking about that. I mean, I think Carolyn Pachetta wrote about that as well, or mentioned it, and she also is the author of this week's Volcano Watch, which we'll talk about a little bit later too.
Yeah, for sure. Yeah, interesting how much has changed. So yeah, as we prepare for that 1 year milestone coming up in a few weeks here, we'll start to synthesize some of those things a little bit, and yeah, we'll do a little bit of the maps today for you guys. But to start it off as usual, let's get into the weekly summary here for Kilauea. And start off with this image that Dane pulled for us. Let me kind of zoom it out here to get the same full size here on the screen. And you see our persistent lava lake right here in the middle with a couple ooze-ups. One ooze-up over here. This is the northwest corner of that crusted over lava lake. This whole area, hard to tell in this photograph, but the extent of about like this is all crusted over lava. There's lava underneath that entire area. And it circulates up in this lake and then oozes up around the perimeter. And in this photograph, you happen to catch two at once. This is the morning of September 4th. I believe that was Monday. So one here in the southwest and one in the northwest. So cool. And I thought I would juxtapose this with the one we had last week, right? So there is the ooze-up flow from last week that was more so in the northeast. I'll flip it back and forth for you guys, and that was there this week, last week, and the week before that, a little bit more in a pre-dawn, but you see the ooze-up flow over here in this western side. And that in comparison to some of the days where we've caught the sunrise and all you see is a persistent lava lake in the middle with a little bit of glow from that west vent area right in there. So a little bit of a visual summary here, but the best way really is to turn to our KW camera, and this is a time lapse for the last week from that KW camera, courtesy of the USGS HVO. And in it, you can see those ooze-up flows here in the northwest. There's actually another one here in the southwest that doesn't pop up on that earlier capture. And you can see it cycles through here. And it's easier to see these when the captures at night rather than daytime, where the flows are still moving, but it's not glowing as obviously in contrast to the surroundings. So, but that's the same pattern as we saw more or less last week, and overall I'd classify it as fairly active with the ooze-ups, right? We've seen some weeks that have only a couple ooze-ups or one, and it seems like for the last 3 weeks now they've been fairly persistently ongoing, right? Maybe not all the time, but pretty often. So viewing is very good for that reason, if you can catch one of those, like, as we showed you guys in our feature last week. So here is a current view from the KW camera from the USGS website, and let's see if I reload it, if I can get it to come up reasonably quick. Yeah, there it is. And see, there's the sunset shadow. Looks like there's some clouds that are casting a shadow over the crater. Not a whole lot of glow visible yet, but the light's changing and good viewing's coming up. Different point of view. This is a S1 camera from the south, looking once again at the persistent lava lake, and we're looking just at this west half of the crusted over lava surface. So you see, this is the northwest ooze-up zone, and the southwest ooze-up zone would be bordering on a screen over here on the left. So there they are, and otherwise pretty steady in the middle. You see continuing glowing spots with gas venting here, glowing spots there and there as well. This is near that central island that still remains buoyant, right? That's the core or the heart of that crust that's floating over top of that lava lake, and it seems to be rising and rising and rising still as lava fills underneath it and kind of fills the moat around it as well. So that's the pattern. as we've gotten used to seeing here. Nothing really stands out. The ooze-up flows are still amazing every time we see them, especially when they're very photogenic right in front of the camera, like this one here on a f1 thermal camera. Second one here, it's slightly off to the side of the camera, but you see these secondary overturning, right? It's kind of this crustal foundering process that the geologists have been describing for years now, where the crust forms and then it becomes heavier and cracked, and the gas underneath is building pressure, and it can kind of pop it through and then kind of resurface it, overturn the whole thing, and create a new surface that freezes and solidifies on top. So you see some of that as well. And otherwise, looking a little more closely at the persistent lava lake, you can see the west vent is just fuming away here, glowing steadily, and so is that main persistent lava lake. Looking at that southeast pit over here, you can see it looks a little bit more like it's flashing, so you can imagine with that smaller area, depending on the pulse of lava in here, it's probably forming a little bit of a crust and breaking a crust and over again, because it's not quite the same input. It comes in from this west side and then curves to the east and goes through that little lava tube to get into that pit over that way, as well as going to the east sink and to the northeast sink that we'll mention as well. Business as usual this past week. Here's the most recent f1 camera capture from the USGS. Let's reload it here, and still looking the same. We'll cycle through. There's a S1 camera from the south once again, and similar views. There's nothing surprising jumping out at us. It's just kind of been the usual great views here. Zooming in on the lava lake itself with the V1 camera here. That's the current view, and let's go to our 1 week time lapse and play it through here. So once again, circulation from this point of view comes in from the bottom right, and over this way, and also coming over this way, right, and also coming over this way. And don't really see a whole lot of variation in the lava level. You really don't see any change in the shape of these benches that are forming here on the side. You can see there's a little bit of a terracing. One level right next to the active lava, then slightly above that, and then slightly above that, and another one back over here. And you know, this can happen as the lava lake is closing up. But remember, this whole crust is also getting pushed from below and lifting and rising and bulging and spreading. So as that it tilts and moves and things, you might have that kind of pattern occurring, as well as when lava output actually drops, and then it has a chance to solidify at a lower level and form another bench and kind of contain itself a little more that way as well. So that is the close-up view of the lava lake, and let's see if I can go in on the southeast pit a little closer here and really see how it's inset there, and not as nearly as much spatter compared to what we saw that formed this spatter cone feature here on the backside of the southeast pit. That is the webcam version there, but we will show you guys some of the photographs released by the USGS this week. Most of these are a batch that goes back to September the 2nd. So let me put on here that we are doing our media of the week. So this first photograph is a panorama of the crater taken by Katie Mulligan here, and it's showing the active lava lake. Let me kind of go into the zoomed in version. There is the active lava lake with that pit. See all the fuming spots down on the crater floor, but farther up on a crater rim, you see all the layers of old flows that were part of the shield building phase of the volcano a few centuries ago. And then up on the top of the cliff, here's the Wikahuna Bluff with the tower at the former Jagger Museum HVO building, with viewing areas over here on this side and over here on this side. Now, the ones that look into the crater. Let me zoom it back out here. And back down here on this bottom left corner right over there, let's zoom into that, and there is that cracked piece of the old crater rim drive And so this picture is taken from the south. And then this would have connected the south to the north overlooks over there. So interesting to see how that's all holding up down in there. Continuing on our media, here is a photograph by Jay Chang, and it's a photograph captioned, HVO geologist uses a telephoto camera lens to document Kilauea summit eruption from the south rim of Halemaʻumaʻu on September 2nd. The slope of Maunaloa's northeast rift is visible in the background on the left side of the image, whereas the summit of Kilauea at Wikahuna Bluff is visible in the background on the right side of the image. So there's the summit of Kilauea. You can see it, the high point of the crater rim right there. And there is that northeast flank of Maunaloa back over there. And she is looking through the camera and taking some telephoto photographs. And what we see next is, in fact, the series of photographs that are shared from that effort. So, coming down to look at the captions first here. This one, telephoto view of the eastern end, where lava flows erupted over the past year intersect the crater wall. The fissure that erupted in 1982 on a caldera floor is visible as a ridge-like feature about 130 feet or 40 meters above these lava flows. So 130 feet, 40 meters, let's go to the full image here. There's a distance between that ledge and this lava level down over here. Right. And that's that ridge that was the fissure that came across the old Halemaʻumaʻu crater floor. It actually intersected the old crater wall and went down the crater wall and erupted on the floor of Halemaʻumaʻu as it existed back in 1982. But that's the rampart that remains. And so if you were here and visited the national park anytime prior to the closures in 2008, you could walk across a trail, and a trail came across and went by the spatter rampart, and you could see some really cool features in there. But that's been a while already. But really interesting, the fascinating thing is how much it's risen up, how close it's getting to this level right over here as the crater is filling up. So this is that next big area of down-drop block for it to flood. But it's not quite there, obviously, with that 40 meters, 130 feet to go, on this eastern side at least. This does slope downwards off in that direction to the north, so it does start overlapping it further over. But we'll get to that here shortly. One last point is that this is the area where we believe that B1 camera is positioned, is somewhere over here on this rim, and it's looking into the crater off, something like this. And I believe if I zoom into it somewhere in the right spot, we can maybe, right there, maybe make out what appears to be a very blurry solar panel and instrument box right there. So if I come to the rim, can't quite tell, probably guessing right there, that's probably the tripod with a camera right in there. So harder to see if I put it back to the regular view. There, connected to there. And that's just a little dot right over there on that rim, if you're curious where that camera actually sits. So great to see those new views from USGS. Here is another telephoto view, looking more closely at the lava lake itself. Here it's noted that the lava lake is approximately 3 acres in area. That's 1 hectare, so pretty big if you consider it compared to the size of a person or a plot of many houses, right, in a city. However, lava flows from this eruption, which began on September 29th, 2021, have covered approximately 282 acres, 114 hectares. So that puts that active lava lake surface at under 1% of the whole area of the crater floor now. It's actually under 9%, under 0.9%. Close to that, actually. So we can come in here and get some closer views. It's maybe not the best to click through, but there are some different angle views and visuals here of our ongoing eruption in Kilauea. Let's see, a really yellow spot back in here. This looks like maybe is that some sulfur, or maybe that's something in the air. It's not quite clear what that is right there. Or maybe it's just some fume lit up by the sunlight. Maybe is what I'm looking at now. All right, so one more of these zoomed in photographs and looking more closely at that southeast pit. And as they're calling it, the much smaller lava pond, and lava flows that appear darker gray and shiny around this feature attest to recent overflows. So what they're showing here is this change in coloration, right? Where you see this darker color that seems to be on top of this other color stuff apparently here. And maybe back in here, the silvery stuff in there might be some of the areas where it's been overflowing as well. Not quite as clear in here, but that's my best guess of what they're referring to. So that's our media of the week. So switching now to our lava viewing, let's look at the park map of our viewing locations as usual. Lava viewing report here, and here is our map of Kilauea caldera at the summit of Hawaii Volcanoes National Park. And the 3 viewing areas as usual: Uwikahuna in the north, that sees that eastern side, and overflows, ooze-up flows when they occur over there, and all those fuming vents and topography on the crested crater floor. And we've mentioned before, Kupinaʻipali, Waldron's Ledge. A view from that area in the east is the most accessible, closest, shortest walk. Often not very crowded, so you can check on there as well. And we're back to showing you guys views from Devastation Trail parking to Kanakako'i Overlook over here in the south, and that's what we'll feature from 2 Pineapples here shortly. But as I mentioned before, you can see on this map here, here's that ridge is that 1982 fissure right in there, so that web camera is positioned somewhere right in here. So it gets a view, something like this. You can see that's not too unlike the view you get from Kanakako'i as well. So we'll compare that shortly as well. So the B1 camera, let's load up that recent view. Here it is. Reload it, get a little bit more sunset in there by the looks of it. Lots of fume here in the foreground. And I'll point out this pair of steaming cones right here in the foreground. You can just notice they're about in the center of the image. So we have from the cone to that active lava lake, that's that part of the field of view is just this back third here from this camera, and we see quite a lot in the foreground from this B1 camera right here. Let's look at the last week animated, day and night. And you can see mostly fuming. Most of the activity is happening on the far side of the crater. Most of those ooze-ups are occurring back in here and back over here. Right, you see the day-night fuming, but you might notice that there are other spots of glow. There's glow coming from different spots in the crater floor, there. From this cone, actually, you see a couple of glowing spots there. There's one over here on the left, and a couple together back in here. Might be hard for you guys to see, so I'm trying to highlight them right in there. So there are other spots that are glowing persistently as well, so note that too. So that's the B1 camera, which is a good proxy view if you're curious what you might get to see. But we'll turn to highlights from 2 Pineapples this week. Mahalo you guys for sharing as always. Really great stuff, and your viewers are really lucky to have you guys streaming so often. And so I just wanted to show that view and maybe like start it back over here, rewind it. Here's a view from Kanakako'i, right, of that crested lava lake area. And this is that edge of that down drop block in the foreground right in here. So as we zoom in, you can see there the edge of the down drop block. And just the top of that left cone, and you see the right one as well right in there. So we're missing that whole front of that field of view, right, is hidden behind this ledge right in here. So it's a little bit optically challenging. So we'll flash back here to a view in the nighttime where it's more obvious what's what, and there's that glowing lava lake with no big ooze-ups obvious and at this particular instant in time, back on the 5th. And the really awesome views of the lava lake circulating, dropping in. Here's that northeast sink. I've got everything sped up here. And there's that eastern sink. And everywhere the lava is sinking back in, it's spattering up. And you can see how they've got this awesome multicam system going. You can see various views at the same time. There's a little bit of an overlook in set, and moving from overlook, looking at some of the features around a caldera like the tower, lava lake. There are some more of these fuming cones all around the crater floor in comparison to like where they are compared to the lava lake. Different views of all kinds of topography, and that's fuming, and after a sunrise these guys do an awesome job of highlighting all that stuff and sharing, and just got a few real quick clip styles for you guys to try to share a little bit, but you really got to go and check out their live streams to get the full impact here. So here, this is interesting. There's a couple of these hornitos or spatter cones that look like they might be glowing. This is not clear if it's exactly glow or it's the sunrise reflecting, possibly. I suppose that's possible, but some of these other ones looking more convincing they actually are glow, and considering that we saw the glow coming from the B1 camera, that seems likely that they're catching that too. So that's why these early morning or late night views are the best, when you can really see that contrast and pick out these different features. And the last view of that first cone we saw, pair of cones we saw, and here, this is a tip of that one of these old islets, the small little islands that were, not the big one, that were floating originally on that lava lake, and then the crust kind of came all around them. It's overtopped them and overflowed them a few times. And it looks like now, presumably they were floating because they were a little bit less dense, right? Not like a solid rock, but maybe some of that spatter we saw from that first fountaining event. So more cindery maybe is a way to think of it. Which means that the gas could possibly move through there more easily and degas through these sites as well. And we've seen that not just at the islets, but also at the central island as well, that big one, large island in the middle. But this was pretty cool to see this updated view where the whole top of this islet is covered. This might be the sunlight hitting it, but it looks like there's some sulfur on there as well. It's hard to really tell, but when we zoom it in there, it looks like there's some sulfur in there, yeah, for sure, not just the sunlight. So pretty interesting, and there's that wider view of that whole crater and all those different spots fuming. So once again, mahalo to Two Pineapples. Check them out on YouTube. Go like, subscribe, and support them. They support us, as you guys can tell. So before we move on from lava viewing, I wanted to highlight a couple more things. So this week on Hawaii Tracker, we had a couple of posts of people. I haven't looked through exhaustively, but I just picked out a couple that were representative. But here is one from David Nadolny from September 6th. And pictures from my lava adventure last weekend at Hawaii Volcanoes National Park. And so I'm going to come and go through and just show a couple of these for you guys. Pretty cool. Catching the spatter burst. And the long exposure there. In the lava lake, there's another spatter burst. View of the glow reflecting on the clouds above the trees. So you can see all these spots of lava spattering on that edge of the crater there. So pretty cool. I'll highlight one more that's similar. This is by Kim Guastella, and you see here she's got similar kind of photographs with that spatter burst on the side there, but we also have from her a video posted, so you can see quite similar. Obviously it takes a nice lens to get in this close when you saw that field of view before, but as you can tell, it's not just the pros, right? Like pretty much anyone can show up and get good views. So worth mentioning that, since we often highlight Two Pineapples. They're the most often, but we do appreciate the posts from all our other contributors as well. So mahalo everyone for that. One last note on lava viewing, as always, check the National Park website for current conditions, closures, all of that stuff. Right? And check out their map and what to bring and views and all of that. It's a well updated webpage here, so check on that. So since we were talking about viewing and we're looking at the park website, we'll transition to looking at volcanic hazards. Our hazard for this eruption, as we've mentioned multiple times, every time, is the gas still, because the lava is within a national park. It's contained within the crater. It's not going anywhere over top of ground or underground, not heading anywhere else in any significant way. So it's all contained within that crater, and it's just the gas that's flying around outside impacting communities, and depending on the wind, of course, and the emission rates. So here is a current park map. Everything is in the green. You can see currently it's showing weak winds where it's just got a big blob of where the gas may actually be. This is a fairly generic look at the conditions, but good enough for most people. Since we're diving into things here, we'll go into a little more detail instead of looking at just the green. We'll scroll back by site, and if you scroll back by site, you can see that there's a pretty obvious one site is all in orange. That's Kahuku Facilities SO2. Has been in orange for, looks like, most of the past 24 hours here when this was loaded earlier. And we can look into that a little bit more. First thing to note is the VOG forecast from the VOG mapping project, VMAP, from weather.hawaii.edu. And you can see that. You should know that on a map, Kahuku is down in this area right in here. So it does appear that the winds are such that the VOG seems to be hanging out in this summit to South Hawaii area more so than it does some weeks. It's really just kind of lingering there, so you can really see how it's just sitting here. This is a future forecast for the next day, so it's likely to hang around even longer from what's happened over the past 24 hours now. But gives you some idea, and you can see it's wrapping around into Kona a little bit too as well. So that said, we can now go to our purple error monitoring station map, and we can come down here. These two sites down on the bottom, this is the Kahuku sites, and right now it's actually back into the green, but look at the plot here. Let's see if I can get this to zoom in. And you can see that it's come into the yellow and been in the yellow quite a bit here over the last, goes back to 6, yeah, so last couple of days here. And that's one site, and there's a second one. Let's see if I can click it. And we get them both here in the same graph, and not as much at the second site, which is the orange on the plot. It's jumping up above recently just once, and more so in the last couple of days. But you can see it's certainly impacting that area. Otherwise, we can look at places like South Kona, Lionsgate Farm. See coming up into the yellow and back down, or places like Pāhala. Which is still seeing some of those gas plumes swinging through that sometimes hit yellow, but sometimes don't. Okay, so that is the hazard summary, and of course it depends on the gas emissions, so we'll look at those as well. But that really transitions us into our Kilauea monitoring data. So here is our 1-month summit SO2. This is the integrated measurement from USGS HVO that's looking at all the different emission sources across the summit caldera as much as possible. We're still waiting to hear more details about that, but that's the goal. It's always been the goal. And over the last month, you can see not as many data points in the recent times, but the most recent one we have is right in here. In case you can't see it, it's right there, and that comes out to about 2,000 tons per day as the most recent measurement. I want to say it was on Tuesday, on the 6th. One before that was back here at 1,400. Before that, it was 1,200. Before that, it was 1,700. So really, the last three, it's been a little bit lower, and it seems like possibly coming back up, but I hesitate to draw any lines between here just because there's so much missing time in there. But overall, this more recent trend, if I were to draw a line like that, does seem to mirror what we're seeing here in a tilt, right? With the exception of this little deflation-inflation, which could have happened and been lost in there, and a little one that's we're coming out of right here at the right end of the graph at present. So overall consistent. And looking at this 1-month tilt plot that we're just talking about, you really see this division and pattern from before the 19th, where we had these very rapid back-to-back short deflation-inflation events, and then since then it's been more of a steady rise with occasional deflation-inflation events, like one that occurred a couple weeks ago, and then the one that's ongoing this past week here. Right, the one a couple weeks ago did have a similar V-shape, but the one ongoing now does not appear to do that, which is interesting. So, and likewise, harder to tell right here, but let's see if I can highlight this a little more easily. But the lava depth, it's a little bit blown out by the plot, but the trend that it was on was about like that. right? And you can see that here at the right end of it, we're deviated higher than it. So really, it seems like the rate has come up a little bit in this last segment as well. That corresponds to that same tilt ramp up here. So it's climbing again a little more than before. You presume that means the output rate is up a little bit from what it was before as well. But we're still awaiting the most recent maps and volume reports to be able to assess that. Zooming in this past week, here we are, coming out of the most recent deflation-inflation event. It's more this U-shaped rather than a V-shaped. It has a couple of these spikes on it. If I zoom it in, you can probably see that better. But there's a spike right there. That's from the earthquake that occurred last night. And if we come back, we can see a spike and actually a small offset that occurred from the earthquake back on the 5th. My little offset jumped up and actually adjusted it. So if you were curious, I saw someone came in right away, was wondering, did these earthquakes have any effect on the volcanoes? Based on the ground tilt at Kilauea, we talk about Kilauea, you can see that no effect really, nothing really changed. They just went on as if nothing had happened here in a more recent one, but the first one did seem to cause a little offset, so the ground did shift a little bit, but it was a very minor shift, and you can see that the scale of this change of the earthquake, which is about that much, right, doesn't really compare to the scale of how much it's swinging up and down on a regular basis anyways. So a very, very small effect, but it didn't really change anything eruption-wise. That's kind of a good way to see the relative impacts of those different forces there. And then scrolling down to our summit lava depth for the last week, you can see it mirrors the last week tilt pretty closely here in a general pattern. You can see it's coming up fairly steady with a little bit of a gap right in here we'll discuss shortly, but and then coming down a little bit, corresponding to the more recent deflation-inflation event. So that's all well and good, and we've seen on here that there are these small variations. Let me zoom in now on this a little bit more. So we see these small variations on here, and this is not exactly a tidal thing like we've seen on other tilt plots, right? Because you see it disappears for a segment in here. So this is likely to do with the output of lava, whether the lava is kind of pulsing out, or whether there's a gas that's bursting, or some kind of some effect like that that's got a small scale cyclicity, whether it's just the lava circulating in a lake and spattering, and that spattering causing the lake surface to be agitated and moving and undulating. That kind of thing can occur as well. The measurements we're looking at here, this is 20 centimeters between there and there, right? So like some of these changes are like just 5 centimeters up and down, or 10 centimeters up and down, or in this case it actually is 20 to 30 centimeters up and down right in there. Right, and it's small changes, which is fascinating to see how they actually seem to turn off, right? So the lava level stabilizes, the small scale cycles seem to stop. So is it possible that maybe whatever was bubbling into the lake maybe took a little pause, a little break for a day or so before resuming? Meanwhile, at the surface, really no change. Lava keeps circulating in the lava lake, and then we see the ooze-up flow is continuing as well. So, but interesting to note that this is just very, very minor details. But when you get them, since these plots are automatically scaled every week, right? If it happens to scale in such a way that you can notice these little details, and it's worth pointing them out. You don't always get the benefit of that. We don't have the option to rescale it as we like, as they do internally there in USGS. So big picture, here is summit lava depth from 11.5 months ago until now. And that rapid rise at the beginning right there, and fairly steady coming up, maybe slightly less in that interim period through here, but still climbing steadily. Looking at the GPS, this is summit GPS Kilauea, and the overall big picture pattern still continues. We're actually have been climbing fairly rapidly compared to what we were doing earlier as far as the spreading. This is the edges of the volcano getting pushed apart, kind of bulged as magma pushes below and spreads it apart. But zooming in, as usual, we have some of these little variations. You see there's quite a lot of swing up and down that can occur depending on small scale adjustments, and it appears something like that's going on here at the right end, since it seems to be doing some kind of wiggle. But as we've seen in the last few weeks, the data that comes in this most recent couple of weeks is often refined and can move around and improve over time. So nothing alarming that we can tell from now as the bottom line, and everything looks like it's business as usual there. And likewise on that Middle East rift by Pu'o'o, where you still see that fairly unchanged pattern, little wiggles as well, but nothing major noticeable there either. So big picture, that's where we're at. That's been, you know, that's almost the whole last year, right? This almost a year ago signal when it was climbing quite rapidly and then relaxed. That was eruption beginning and allowing that pressure to decrease, right, as a lava burst out. And then really since that first month after that, or really a few weeks, it's held steady and been climbing, refilling ever since, right? Which just goes to show that the magma is coming in and filling not just the crater on the surface, but it's also filling the network underground of that same area. So it's bulging underground and oozing onto the surface too. But all only within a summit, as this bottom plot still shows, right? So along those big picture lines, I thought I'd show you guys, this is the F1 camera for the whole eruption that Dane put together for us. And you can see I got it playing, it goes through fairly quickly, but this is the whole last 11 months. And the more recent pattern you see now with the lava lake persistent and ooze-up flows around the perimeter and really no pauses and ooze-ups. In contrast, this first part is flashing through again. You can see it goes dark. You see flashes coming, especially in this west vent area in here. And then now, by mid-year, it's settled into the pattern we're seeing now. And so let this loop through one more time again so you guys can tell. And look for that change here at the beginning. Not just larger lava area, but actually bursting forth, like from these areas, these flows that are coming off like that or like that. That seem to cease, right? We've seen this West Pond vent still liquid and circulating and rising and falling, but it hasn't really overflowed that we've seen in quite a while. It's kind of one data point, if you want to look at one spot in particular to focus on right in there and whether that thing's oozing out or not. That's the long-term pattern. This is just part of our ongoing review because we're coming up on that milestone, as we said, in a few weeks here. And along those same lines, here is a compilation of the maps, the USGS maps, and I've zoomed them in for all the last 11 months. So the area in red is the active lava, the area in pink is the crusted lava, like overflows that then harden, and the yellows are the islands. And so you can see a few things happening. You know, if you focus on one color at a time, the red obviously shrinking, the active lava surface has gone from covering everything to now, as you mentioned, less than 1% of the whole 114 hectares, or 282 acres. And the islands are interesting. The islands, the yellow, you can see that they actually sometimes shrink as the lava overflows lap onto them and cover some of the edges. So they've been changing shape a little bit as well. And of course, the salmon pink color margin of the overflow is coming in on the northeast and the northwest here, making these cat ears, as I've called them before, are pretty striking. So I think it's worth looking a little closer. Let's maybe zoom in. We'll zoom it way in for you guys here, and we'll look at the overflows on this northeast side, since we can. And we were looking at earlier of a photograph of this fissure, the 82 fissure, right? And the lava was only 40 meters below it right there. And so that's kind of that view we were looking at before. And here is that lava filling in map view, that area. And you can see how far up it's come in that time. So that's just kind of one point. Let's wrap it around and look at this north. You see it's climbing up this ramp off in this direction. Got a little bit of a gully in here, but you see it starts turning and flowing down these downdrop blocks, smaller blocks that have cracks on those sides like that one, and starts flowing off like that to the sides, filling the area, showing it's hitting that steeper topography to the east, but it's going to fill in this bottom part as it wraps up in both directions over there. That's pretty cool. You start to see that kind of jagged look like that, right? That's what I'm talking about. You catch it right in there, like right there. And likewise on the other side, looking at the northwest cat ear, here we are lapping up. We see we had an inner ledge down in here that's been all the way buried already. The next ledge that was over here in the north is almost all the way buried already, and now you can see it's all the way gone, with the flow coming up and around and starting to sweep around, and we're going to see these two cat ears come and pinch and join together here in not too long as one of these next phases. You can see a little bit of that flow coming off in that direction right in there. So that's that downdrop block, and of course it's going to be bounded over here in the north, and it's going to want to have to go off, eventually off in that direction. Let me pan it back around. This whole south side is all really steep, and it's going to just be bound there and not come out until it climbs a long, long way. But there is on the southwest side this other down drop block. That's what this chunk of land is right here. That's the down drop block right in there. And so the lava just behind that west vent complex has been coming up closer and closer and closer. You can see it's right at the edge and starting to overlap onto that block as well. You don't see any big flows coming onto it quite yet, but you see it's come up the cliff where that darkness of the cliff is no longer visible there anymore by this last frame right in here. So this last map is from 3 weeks ago, so look forward to the new one possibly next week, and update this once again. But that shows you in map view a little bit more the zones that are changing, right? You can see that it's steeper up here than down here. It's a little bit more sloped, right? So it seems like the lava might be able to come in and start putting in fingers possibly in here as well. We'll look for that as time goes on too. So that'll be our next area of attention that we haven't looked at really at all thus far in Eruption. And can't wait to see those changes in the landscape. Right? That's one of the fascinating things as a geologist about this, is just really seeing the ground change like over a human lifetime, over the, you know, you can come and visit Hawaii and see something 1 year and come back again 6 months or a year later and see something completely different in the same exact place, which is really fascinating. So that's always what's caught me about Kilauea. So that is our integration of monitoring data, and we will switch to Volcano Watch. And Dane, if there are any questions about any of this stuff, you can feel free to jump in here. I'm just gonna review while we finish monitoring the Volcano Watch first, and then we'll be able to
all right,
wrap up Kilauea. Okay, so as far as Volcano Watch this week, here is the article, and it's announcing the completion of the lab, which in itself is great. But they give a little more detail as what all the instruments are in there that are being used. So let me see if I can get this a little bit bigger. So I'll try to summarize. It's a unique combination of 13 instruments that provide new insights into the density, size, shape, and componentry of volcanic rocks. So of these, they have ovens because they have to dry any rainwater out of the rocks before they can do any analysis. So they have ovens. They have density measurement instruments. Some of those, I mean, that density is a tricky thing because it's hard to calculate the volume of a rock. It's not an even cube, for example, right? So different approaches are taken for that. One is basically doing a thermal vacuum, fitting a waterproof plastic sheet around a rock. It happens in a few seconds. That's way faster than the old way of waterproofing using wax. There's also, I'm not sure how you say this word, pycnometer, that they're using to measure volume. That is, there are 4 of these instruments, mostly for measuring ash and foams. And by foams, they mean things like reticulite, rocks with bubbles. Reticulite I've often referred to as our Hawaiian version of pumice. So very, very light, frothy rocks from the foam of those lava fountains that occurs. High fountains for the most part, usually. Most often those will be used for density of samples like ash or fragments up to golf ball size, scoria reticulite. There is a 6th density-oriented machine as a 3D scanner that scans it and calculates volumes from the 3D scan. They can do from golf ball to football size samples. And also can be detached and taken into the field for larger objects. So if they then have the density, or if they then have the volume and they have the mass, which is easy, mass is easy, then you get density. Then you can go to particle analyzers to analyze size and shape of the grains, and they have different ways of measuring that. And the reason that's important is that tells you how the lava actually erupted, whether it was explosive, how much gas was in there, what process it went through in the eruption, which can give a lot of clues to the scientists. So normally they measure size by sieves, actually just sieving the different things through larger holes and slightly smaller holes and slightly smaller holes and slightly smaller holes, on and on and on and on. So which obviously can take a long time. So there are some new ways of doing that that kind of streamline that whole process, right? So one of those is something that's been reviewed in Volcano Watch before, is the photos of particles. Like they basically drop the particles and take photos of them, high-speed cameras, and automatically they analyze area, perimeter, and shape, all kinds of things that are processed by the computer. So that can go up from about an inch to less than a thousandth of an inch, 0.8 microns, and anything larger you can sieve, right? And that's like the big stuff's easy to sieve. The little stuff is where it gets to be a pain. The smaller and smaller it gets. And then finally, for microscopes, 2 stereographic microscopes for looking at the visual characteristics, whether it's glass, paleosteers, ash, or lithics, minerals. And then also petrographic microscopes that help you look at the minerals and bubble textures, those kind of things. More of the mineralogy and that type of history. So that's what a couple of those look like. Let's zoom in here. There's a, let's see what it says. The left image here is the 4 pycnometers that determine volume and density. That's these ones, volume and density. And then on the right, I believe those are the particle analyzers. Right? Particle analyzers, a cam sizer with a high-speed camera with these funnels of different sizes here to dump stuff in. So pretty cool stuff there. So we'll look forward to actually seeing USGS share results from this lab at some point, which is awesome, right? And it's not just for Hawaii, but also other volcano observatories and collaborators across the globe as well. So that is Volcano Watch, and that is what we have for Kilauea, with just one final note that, of course, all this data coming from the USGS HVO. Here's our most recent daily update from today, and it's saying same thing we're reviewing here, right? No significant changes. It's still continuing, and hazards are still a gas. Otherwise, no changes. All the numbers are documented in here, but that's where credit is due, and we'll give it there. So we still have coming up the earthquakes, but you got something in right now, Dane?
Yeah, I was gonna say, like the USGS's new Saran wrap machine to calculate volume. That thing's pretty cool looking. No,
yeah, yeah. Maybe if you need to repack your lunch after.
Right. You know, yeah, so make it multi-use in there. Do have a couple questions, but first want to acknowledge some super chats that came through on the YouTube. First one was Chris Kiki, who said, who had a $20 super chat, says, "Thank you, Phil and Dane, for all your hard work and keeping us informed. You're very appreciated. Appreciate the support there, Chris." We had 12 time come through with a 1999 super chat, says, "Keep up the good work, guys. Appreciate that one." And finally, we have longtime supporter Gary Bryan coming through saying, "Thanks, Phil and Dane, super analysis and review." Thank you, Gary. And with that, do want to we take this opportunity right now, get this out of the way. Thank the County of Hawaii as well for their support, their funding, and through the VIVI grant is going to be producing content, continuing to ensure that content is produced for the next year. So we're very appreciative of the county for trusting us with this venture. I mean, it's getting easier now to explain to people what it is we exactly do. But, 3 years ago, it was very abstract and hard to communicate with people about, because they wanted to see things into very defined boxes that they're accustomed to. And what we do really isn't that. So we appreciate that trust. I think with that, though, we can get into a couple questions, unless you have something to say there.
Yeah, and mahalo, County, Hawaii, and yeah, for sure. This might pivot into one of the questions we have here, right? Which is, I'm not sure who asked this, but is it hard to keep people's interest? I get a sense of no surprises, no issues, no problem, no worries or hurries. Right? I think that's a good thing to talk about right here, right? Their whole mission with this is disaster preparedness, and yeah, we prefer to do that when people aren't concerned for their livelihoods and for their houses and pets and animals and all that. Like, we went through that in 2018, so we are just fine with doing it without imminent threat. but we think it's important to keep doing it persistently so that we can be better prepared the next time it comes around, right? And not just us, but all of you guys who are watching our community online, whether you're residents here or elsewhere, will be able to help us when that happens by being educated and sharing all this information that you guys are learning, right? And helping people manage expectations of how these things go down and what to expect and all of that, right? So sometimes people react differently. Some people after 2018 were very traumatized and they really need to keep checking in, make sure everything's all right all the time, and that's how they're able to sustain. Other people need to actually, check out, and if there's nothing going on, they don't want to see it or hear it, and that's totally fine also, right? Sometimes it's too much, for sure, right? We get it that we're not like everyone as far as our interest level never drops on Kilauea, regardless of what's going on. But yeah, right. Really, it's the mission that keeps us going after having gone through 2018 and seeing all that suffering and knowing we could do better and wanting to do better the next time. That's kind of what we really appreciate County of Hawaii support coming through and helping us work together, establish the relationship ahead of time. So when something does happen, we're working step in step with the county, right? Rather than butting heads or being out of sync, right?
Right. Not only that, like in order to do the private side of things with that approach, I mean, what this does is it ensures that we don't have to sell out to basically hype in order to get views and things like that. A lot of the YouTubes, I mean, people that go through it, the channels are aware. A lot of it is a lot of hyperbole, a lot of hype, and they do that to get attention. They have, flamboyant thumbnails and things like that. We don't want to do that stuff. So in order to not have to go that route, which we see all too commonly, and be able to still speak and be able to, be ready for the next event, this is the path forward. So we appreciate them, and with that, I think we can continue with the questions a little bit more. SAS Adventures asks, will the lava filling in the crater from the last two eruptions solidify, or will this become a magma chamber of the volcano? This is a question we've had a couple times, but it's been a little while.
Yeah, I mean, it could solidify eventually if it stops getting new magma and lava in there. That's ultimately it, right? If you kind of keep supplying it with new stuff, then it's not going to cool down very fast. It will eventually, right? But it's not going to cool down very fast. And it'll cool to edges, so really the edges, the boundaries where it's able to radiate heat out into the surrounding rocks and into the atmosphere across the surface of the lava lake. Those are the areas where it's probably crusting and thickening. But there certainly is a gooey middle in there, right? That's being fed from below and replenished with the hotter lava, more gassy lava that's able to keep that stuff fluid in there. So if it were to shut off entirely, I think given the volume of lava that's in there, it would probably take decades to centuries now, given the volume that's in there, for that thing to solidify all the way. So the bottom line is it's not going to have time to do that, to harden all the way, and which means it's likely to become some sort of, I mean, it's part of the magma reservoir system, right? And you could think of it as a magma chamber, quote unquote, even though that's not the sexy way we think of these things nowadays, right? Instead of like the magma chamber, which implies there's like one spot where it is, it's like we think of it as a network of reservoirs, right? So you can have a small pocket here and a bigger pocket there and a little pocket over here and a bigger pocket over there, and they're all connected in some way. So yeah, that's a long way to say, yeah, you can think of it that way, that it could become a magma chamber of the volcano. So I appreciate that question, SAS Adventures. Yeah, that's one way to think of it. I mean, we try to really explain the process here more so than stick to the terms. I like to try to translate the terms for you guys, but not be bound by them. And so you might get some geologists objecting that to call it a magma chamber, because if the material has been exposed to the atmosphere, then maybe it's not magma anymore, it's lava. So maybe now you have a pool of lava and it's a lava lake, and it's a crested lava lake instead of a surface magma chamber. But it's kind of semantics at that point, is what I'm trying to get at. It's kind of what you call it, maybe less important than what it actually is, right? And so your thought is what counts there. So yeah.
Right. And the final question for this segment is from Dude, who asks, at what depth would a larger 4.0 plus earthquake be concerned for opening a rift that could possibly be a drain for the lava lake?
That's a good question. It kind of depends where. Overall, it would have to be fairly shallow, and by shallow, I mean kind of rift zone depths and shallower, right? So the rift zone goes down to maybe like 5K down, something like that. So we'll call it like 5K and up. Between 5K and 0K, and then the negatives that are above sea level, right? Those are the ones that are the most closely connected to the magma system right now. So what you often see, for example, is like a south flank earthquake that moves the rift zone a little bit, and then the magma from the summit can go into the rift zone some distance, and so that earthquake would be the rift zone opening, or south flank moving to open a rift zone, some combination of that, right? So the depth and location, right? So Pāhala, anything on the Pāhala side doesn't really do it, right? If you had the surface southwest rift, that might be different. You could get magma in there, or lava in there too. But yeah, in the southwest rift, even shallower, probably 1 to 3K down, something like that. So pretty shallow overall. None of these 30-kilometer down ones. That's why we look at it and we're like, okay, automatically, there's not even in a ballpark. So maybe a rock falls over here or there, the ground shifts. Right? Everything is under. It's like a balloon under pressure, right? Like it's just getting swollen, and like you're trying to fill an air mattress, and like some parts are kind of pop up fast. So the whole thing is deformable still, and one shake could settle it a little bit, but it could be for any reason. It could be, from some faraway earthquake that happens across the world that gives it a little shake as well. That makes it settle a little bit too. We've discussed that before too.
Mm. All right. Well, I think that does it for this section on Kilauea. I'll be going into Maunaloa next, I believe, and then a little bit on Samoa. So if you got questions on Maunaloa, go ahead and drop them in the chat, and we will take a look at them.
Yeah, we'll start.
Back to you, Phil.
Start off by looking at the earthquakes a little more closely here, and this is earthquakes on Kilauea in particular, and earthquake rates over the last year, and it's just normal, just pointing out the normal. There it is, within a normal, and we've had other spikes. This was that underneath the summit deep swarm that occurred. When was that? Back in January, and really no obvious link to surface changes, right? We've seen quite a lot happening in the volcano, but really not a whole lot of change that you could link to that. So even directly underneath the summit, these deeper earthquakes deeper down aren't really leading to imminent change. Over the last month, we're holding steady. I mean, it really is up and down, up and down, up and down, and there could be some tidal effects possibly, the kind of thing in there. I suppose it seems like it's the wrong periodicity, but there's some cyclicity going on in here, and but overall within that range of normal. You do see on a red line a couple of these steps. These are the big Pāhala earthquakes, because this plot is capturing everything that occurs in this map. Here's the last week, and that includes this cluster of the deep Pāhala earthquakes gets lumped in with everything in Kilauea Summit and South Flank as well. So the Summit and South Flank are just as fairly low background levels, right? Normal background, which is definitely not zero. We do have one deeper earthquake that occurred closer to the summit, this blue one right in here, and we've had more of these several months ago. They've seemed to slow down a little bit, but you still see a few. There's one there, and one there, kind of offset from this eastern Pāhala cluster. To make it clearer, let's scroll down to the whole last month of earthquakes here on this map, and there it is. And now you see a little bit more clearly the summit region. It does seem like you see a series of earthquakes in this Kīlauea area, southeast of the main caldera. This is over that deeper magma reservoir. We think that South Caldera Reservoir. And it looks like there is a little bit of lineation down here in this upper southwest rift. This is part of that entrance active point into the volcano, and where we saw the intrusion occur in August 2021 before the eruption broke out. So this is all considered part of that same magma system at the summit. It's all kind of different arms and flanges of it, right? We're all through there. And then south flank down in here, there is 1 month of activity. And you see these blue dots kind of scattered all throughout there, and some of these purple ones offshore down in here. So in cross-section, there is those blue dots, and those deeper ones kind of scattered off. This whole deep zone is happening over here. All that stuff is that more active deep background that we've seen since eruption began. So that's the new normal, but still interesting to see that earthquake popping up, and note that those are still ongoing here. Okay, that's the Kilauea earthquakes. Now let's broaden our view, look at the whole earthquake map. So the most recent earthquakes ongoing now, the last 3 have been over, well, more than 3, a whole bunch in Pāhala. But there are a few that are elsewhere. Here's one that's actually farther off from Luihi at 8.5 kilometers down. So Luihi's right in here. So it's a little bit off to the side, nearby there. And so it's likely settling kind of thing, you know, some adjustment of the ocean crust to the changing forces occurring within the volcanoes, and that's the closest one there. And likewise, Mauna Kea keeps doing that, and that's the only other one we see outside of the zone here today. So there's Pāhala. It's really the biggest cluster still, very active. We're still awaiting more information on that from USGS once all that survey and analysis is done. Here's Kilauea that we just looked at, relatively sparse, and then the rest on here is Maunaloa. And of those, you see a few on this southeast flank. There's a 2.0 at 6.7. That one is a 1.7. There's a slightly bigger 2.0, 2.0 down here on the bottom of the west flank over by Maunaloa. A 2.2 at 8.7 kilometers down. That's that west flank. That's one to keep an eye on if this area picks up an activity, but that's normal to have one once in a while there, and otherwise it's all around the summit up in here. So those are the summit events of Maunaloa. We'll look at those a little more closely. However, before we move on, let's switch this view to largest magnitude first, because over the last week we've had 2 big earthquakes, both in the Pāhala zone. The more recent one was this morning. This was at 2:04 a.m. Hawaiian time. There it is, 4.2 at 32.9 kilometers down. When we looked at the signals on a volcano, not really no obvious big change, just a little shift on the surface. And there was one back on the 5th that I mentioned, a 4.0, and then there it is just to the east of it. Right, so there's a 4.0, that's the 4.2, and the 4.0. So that one was first, and the second one a little bit further to the southwest and slightly larger, but likely related, very close in space and time there. And both of those, since they were above magnitude 4, you see a couple of magnitude 3s as well through here, but anything larger than 4 now prompts an information statement from USGS HVO. So here's one from this morning, and it's just stating the data: 4.2, the distance, depth, and part of Pāhala swarm, and all standard, nothing really to pull out from there. And likewise, back on Monday, September 5th, it looks very similar, but it was a 4.0. Same thing, no impact on either Maunaloa or Kilauea volcanoes, part of Pāhala swarm. So, having those noted, we can then focus more specifically on Maunaloa. So here is Maunaloa's summit region, and likewise we're going to count earthquakes, and just in this little summit box right through here. And over the last week, you can see the fairly typical activity we've seen, ongoing pressure building, very low levels of earthquakes occurring. Still noticeable here at the summit, and this cloud to the northwest. And you also see these smaller events that span a broader area here in the southeast, as this whole flank is able to move to the southeast as magma fills in. This is thought to be like a long dike-like reservoir, right? So it's a long, rather than being like a chamber as you imagine it here, right? You might have a small chamber-like thing, but with a long blade that really accommodates a huge volume of magma because it's tall and long. You know? So that's the last month, and while we're focusing more on Maunaloa, let's just call this the Maunaloa summary. And look here at earthquake rates in Maunaloa. For the last month, you can see normal, reasonable variation here. The red line is the larger earthquakes, and you can see incremental magnitude 2s and 3s that seem to be climbing the energy released upwards, but that's just that's normal. Nothing huge happening to point out there. Looking at the last year, we are still a little on the high side, right? Where this whole period of back to, we'll call it July or so, has been more elevated than the period of June back to March, right? That one had, let's call it, about 50 earthquakes per week, and now we're closer to, we'll call it 80 or 100 earthquakes per week or so, right? Which is closer to what we saw before, back February 2022 to September, where we're in a similar higher range, right, as we are to now. Right? And even back in that earlier period, we have occasional spikes that come up, like we had this, which are, you know, little punctuated adjustments. And I wouldn't be surprised to see this level continue to be at this higher level, but even that's not that unusual. To help illustrate that in a little more context, let's zoom out in time to include the whole last month of earthquakes here. So a little more obvious, that summit cluster above the dike, the summit here, and cloud to the northwest, as we mentioned before, and that cloud to the southeast. And earthquake rates over the last 5 years, where they are. So you can see we actually are, these earthquakes per month plots, the last 2 months have been higher than any of the previous year before that, right? So it pick up, but it doesn't actually match what we saw back in the spring of 2021, where it was quite a bit higher, and of course there was an eruption since then. It just shows the scale of what can happen without any eruption happening. So it's got to be bigger than this, or more changes, or more signals, all to be convincing that something's going to be more imminent. So Maunaloa has a pretty large burden of proof to show it's doing something, even though it's often pops up in the news or the internet as anytime there's an earthquake or something else happens. There really isn't anything super exciting to go on right now. And you guys have heard me before. If there was, I would tell you. That's the last 5 years. And looking here at the deformation plot, tilt, just the daily tidal variations over the last month. Maybe some little wiggles, but nothing that really tells us anything useful. And GPS distance, cross caldera change for the last year. This is north to south across the summit caldera, and we've talked about this the last couple updates. This spread that occurs in the data, these variations, you know, whether it can swing up or down, we really have to look at the whole range of it and try to average a trend, perhaps. And it looks like this most recent cluster here on the right is fairly coherent right in there, so that's maybe a little bit more accurate than a spread, which maybe averages in here. So it's hard to tell exactly what's going on, if it's flattened out more or if it's just part of that same ongoing upward spread with small scale localized variations superimposed on it here. So as usual with the GPS, since it's a long-term data set, we have to wait to see what happens next and what the next set of data shows us. And even then we'll have to, really right now we can only talk about what happened like more than a month ago, and we can see the context of it now, right? And as we discussed, maybe since August we're seeing a higher rate, perhaps, if you believe this upper grouping of data points. But now that we're seeing this cluster, maybe it's actually just a little wiggle, right? And we've seen little wiggles before. If we come back here to this as a 5-year plot, and we've seen little wiggles back in the spring of 2021 at a much larger scale than what we're seeing now. So that's still possible as it occurs, as the volcano shifts and adjusts. And Maunaloa, in essence, is a volcano that's filling with magma without having to erupt. It's being injected from below, it's filling, it's spreading and sprawling, it's quaking on the surface, it's moving the ground, but it's not pressurizing in any sufficient way to erupt by the signs that we're seeing from the data. It'll happen someday, but it's not looking like it's happening imminently here. So the vertical, similar kind of exercise, similar kind of spread here in the recent times, and similarly we're having a cluster a little bit more here on the right. We'll have to, of course, wait once again for it to scroll a couple more weeks and make sure it's not going to move once again, but that looks more to be more in line with maybe a slight rise in trend, something like that. Yeah, still, like we've talked about, this is a little subjective and there's a little bit of artwork in here, so really there's only one way to really know, and that's wait and see. Past 5 years for context here as well. So that is Maunaloa. I'll give you guys, this is the Maunaloa update for today from the USGS. Not erupting, no significant changes, slightly elevated seismicity rates above background levels. This last week, 124 small magnitude earthquakes below magnitude 3, so that's a little bit on the higher side. We're seeing more of these 100 plus numbers in recent weeks, and before we're seeing 60, 80, 90, that kind of thing. All pretty shallow. GPS shows low rates of deformation. Everything else is normal, so nothing else to really mention there for Maunaloa. So do we have any Maunaloa questions, Dane, or should we just keep going and roll through to Samoa?
There was one question here where I answered it a little bit, but I bet you could do a better job on it. It was asking, let me see if I can find it. Do earthquakes always precede an eruption?
There's seismicity, yeah. So yeah, the answer basically is yes, but you expect a lot to answer it. Usually expect lots of small earthquakes rather than one single big one. That's really the giveaways. Lots of small earthquakes. Right. You can get some bigger, call them medium-sized ones mixed in there, right? And so sometimes you can have like one big earthquake could set off a series of events that might lead to an eruption, but that big earthquake isn't the eruption itself. The eruption itself will have a bunch of small earthquakes that follow the big one, and that's really what is the magma pushing on the rocks around there and causing the little earthquakes.
Mm-hmm. Right. Aren't there some interesting earthquakes that can happen on Maunaloa as well that are kind of early indicators of activity? Like a Wood Valley shallow thing, like 4 point something.
Yeah, so that's a whole other Maunaloa has a whole other cycle of eruptions and earthquake interaction, right? Where because of the shape of the mountain and it sticks in certain areas, if you have an earthquake that happens first, it can relieve some pressure and induce buildup, which can then eventually force another earthquake, which induces more buildup, and it's kind of cycle like that. Yeah. For sure.
Bunch of different sequences.
Yeah, there are certain locations where those are typically, I'll call them magnitude 5s or 6s kind of things, right? We're not talking about 7s or 8s.
Right. All right, yeah, that really does it for the Maunaloa questions. Really didn't see many of those in chat. If you do have one, go ahead and drop it, and we might try and get it in at the end. And I guess we're on to Samoa. The earthquakes are diminishing, huh?
Yeah, that's the word. So let's check it out here for Samoa. Okay, so here's our Samoa map, Ta'u Samoa summary, and here's Ta'u Island, which is on the Manua Islands, easternmost island of American Samoa, which is east of regular Samoa, as we detailed last week. If you missed our whole summary of the whole history of time zones and all of that, it's a interesting curiosity that occurs back there. So first thing to check in, let's see if we can get the live data to load for us here from the Raspberry Shake. And there's some. We're not getting the full day, but what you maybe can tell, it's not as, if you've been with us and watching, then maybe you can tell a little more easily that we don't have as many of these big spikes on this record, right? They're still occurring here, but they're not as big, and it doesn't seem to be as many. Just quickly at a visual glance. So let's move to, let's see, here's our notice search. Let's do the last 7 days. Let's come to Hawaiian Volcano Observatory, and let's choose Ta'u Island. We can look at just those 7 notices. So here is the one that came up just today, a little more than an hour ago. Still advisory yellow. Earthquake swarm related to Ta'u Island continues. In the past 24 hours, 1 felt earthquake was reported in the Manua Islands. The frequency of earthquakes in the past 24 hours remains low compared to the past week. However, the current trend of decreasing numbers of earthquakes does not mean the earthquake swarm will end. I'm not sure if you pronounce this, FAGA or the FAGA broadband seismometer is recording events, but is currently not transmitting data. The field team will attempt to remedy this tomorrow. Satellite data from the previous 24 hours observed no volcanic activity. So that is the summary. That's just from today. So if I scroll back, you can see what was said yesterday, and they are updating all this other kind of suffix stuff in here, right? Their resources of the hazards is unchanged, and the alert level is unchanged, and monitoring is mostly unchanged. And they're also saying that, of course, residents can assist monitoring efforts by noting and reporting accurate times that they feel earthquake shaking or notice other changes related to activity to either the Pago Pago National Weather Service Office or Samoa EOC in Pago Pago. All right. Yesterday, Wednesday, all earthquakes detected were too small to be felt by people on Maunaloa Islands. The number of daily earthquakes has declined over the past week. USGS staff worked on Ta'u Island yesterday, to complete the installation of a second GPS receiver monitoring site. So, second GPS being installed there. And scrolling down to the previous day on Tuesday. No earthquakes large enough to be felt by people were detected by the monitoring network. No received reports of earthquakes either. So, but they also were able to clarify the current best estimate of earthquake location is approximately 5 to 15 kilometers off the northern shore of Ta'u Island at about 10 to 15 kilometers below the surface. Ocean depths north of the island are greater than 1 kilometer, 0.6 miles at 5 kilometers offshore, and 3 kilometers is 1.8 miles deep at 15 kilometers or 9 miles offshore. Seismologists have determined earthquakes occur in a fixed position within the Earth, so although there is difficulty in resolving the exact location within the Earth's crust, the earthquakes have not been moving from that spot. And that day they were completing a GPS receiver monitoring site. So you see they did one on Monday, one on Tuesday, and that's what the changes in the monitoring network actually are those two additions. And going further back in time, back to Tuesday. On Tuesday, it was no significant change. 14 detected earthquakes that were large enough for people. The largest was a 3.9. So it was really the last couple of days that have been the change, really. And GPS was noted. Installation was beginning. And previous to that, Sunday, no significant change. The preliminary estimates of a band of locations, but since those were refined, we won't read what that says. And 21 earthquakes, 3.2 was the largest that day. And it was similar Saturday and Friday as well, right? So no significant change. 21 earthquakes, largest 3.4. And that previous day, which was Friday, the one we didn't cover last week, the last one here, no change in size or frequency of earthquakes is what they say. Right, so go back to our map here, and here's our scale. 5 kilometers is that far. So they're saying 5 to 15 kilometers north. So if you ignore this box right here, right, imagine that this is all regular island. We're looking at in reference to Ta'u itself, right? If we're looking at north of there, 5 to 15 kilometers, we're looking at something like a zone like this, right, compared to Ta'u Island, where this is occurring. And so it's deeper. It's not on this ridge, and that's why it, in that case, maybe it doesn't resemble what we read as the eruption in 1866, whereas visible coming up through the water and shooting into the air and all of that. So maybe we just look for some kind of pumice or rocks floating, that kind of thing on the ocean, might be, depending on how deep it actually comes out. So that'll be curious to see if anything does happen, what the effects are from those deeper depths there. But that's the best location so far. That's what we have for the update there. Those times, once again, is just American Samoa is right here. That falls into GMT -11, so it's only 1 hour behind Hawaii in the end, even though there was a whole mess of time zones that we covered last week. We won't go into it again this week, but just know 1 hour behind Hawaii is what those times actually are. So yeah, that's the most recent update here today, and there are a couple new photos released just of these tough cliffs on Ta'u. So tuff cone that was formed by explosive interaction of water and a magma. That's what they call phreatomagmatic. interaction of lava with shallow seawater, and it basically explodes all this debris, and it collects and makes these cones, right? And they fall still hot, and they can fuse or weld, or sometimes they can just pile up loose. So here's a close-up of one of these cones, and you can see here the combination of angular rocks that were obviously broken when they were thrown out, and this finer ash that's kind of the matrix holding everything together here, right? And it's layered in these blades. It look like blades as it erodes here, because you basically have material that's a little bit harder, a little bit softer, whether it's more or less welded or fused together, consolidated, maybe more generally speaking, something like that. So that's the base of it there, and yeah, mostly sand size material that hosts larger blocks and bombs up to several feet, 1 meter in diameter, the largest block, 1 meter in diameter. Several tough cones are present near the coastline on the island of Ta'u, photo by D. Downs. Mahalo to the USGS for sharing that with us there, and really that is it for Samoa this week. There's not any more obvious news to share there, and nothing else to really go into. So we are maybe back to a more reasonable ending time here, Dane. It's only been an hour and a half and not 2 hours this week.
Right. There was one last question, if you want to try and take that one out.
Mm-hmm.
Brian asks, how do you tell where Maunaloa ends and the other volcanoes start?
Not easily.
Interesting question. Yeah, I know.
I don't have...
Yeah, I mean, to me, it seems like where you draw some of the lines exactly, somewhat arbitrary. But once it's kind of agreed upon, it's like, you know, that's more important than arguing about like, oh, it's actually 50 yards that way is where Kilauea starts and where Maunaloa. Yeah,
right.
It's rough. And then it's even like, where does Maunaloa actually stop? Do you stop at the sea, at the ocean level, or do you just keep going? Right? Where do you... Yeah,
that's so really the answer there, right? So yes, there's the surface area is fact, right? We know what the surface footprint of Maunaloa is. Like, that part's easy, right? The problem is Maunaloa is holding the torch now, right? Like, the torch was passed from Pāhala and, Mahukona in the north to Mauna Kea and Maunaloa coming. So, the volcanoes were active at different points in time, is what I'm trying to say. So as Mauna Kea was growing, Maunaloa wasn't the size it is yet, right? It wasn't growing yet. So right. Maunaloa and Mauna Kea, they interfinger in some ways, right? And the way to think of it is the volcanoes that are more northwest were there first. So all the new volcanoes are kind of like leaning to the northwest on the volcano that they grew on top of. So they exist on the surface normal, right? But then that northwest side is built on something like Kilauea is built on the side of Maunaloa, right? Maunaloa is built on the side of the next, and so on and so forth. Yeah, that's how you imagine it subsurface, right? So, but yeah, normally when people talk about Maunaloa, the volume of Maunaloa is larger than all the other islands, or it by itself is 80% of all the other Hawaiian islands together. Right. That's from that surface and then extrapolated volume like that, right? So you could go straight down, but it's more reasonable with our current knowledge, right, to think that things are kind of leaning over, and that's something that you could image with earthquakes, or with seismic surveys of some kind. I don't have the results on my fingertips to share with you guys. I wonder what I can find, if anything, here, but
that's all right. Yeah, I mean, Bo just asked, are they overlapping each other? Exactly. I mean, Hua lies on the side of Maunaloa, and there's overlapping there, and then Kilauea is overlapping as well. And they influence each other to the point where like Maunaloa is getting rift zones pinched off, and yeah, there's all kinds of influence between the volcanoes and how they formed, and just because they're so tight together.
Yeah, I can't find a good image right now, but yeah, that's something. Yeah, in the future I'll try to find. Yeah, good question. Thanks for that, Brian.
All right, and I believe that does do it for the rest of the questions. Don't see any others there. My camera had a little issue. Hopefully that fixed it.
Yeah, you're back.
And I believe that does it for this week. Thank everybody that tuned out. We rely on viewers like you to get the word out and get more people to see this type of content. Again, we're not doing all the hype and the clickbait, so we rely more on the word of mouth of people to spread like where they can find real information at. And all the likes, subscribes, shares, those really do help with the algorithm and get it out there to more people. So appreciate everybody that tuned out, and we also do have hawaiitracker.com for a backup that we post content to as well. So if you can't find something on the Facebook or the YouTube, definitely check out hawaiitracker.com. You might just find it there. And that'll do it for me this week. We will be back next Thursday, 5 p.m. Hawaii Standard Time. That's our standard time for bringing you this broadcast. Unless something crazy happens, then we'll go live and cover that. Not really expected, but hey, you never know. So that'll do it for me this week. And I'll pass it back to you, Phil.
Thanks, Dan. Yeah, hope you guys are tuned. Yeah. Thank you guys for checking in with us here. And reminder, in a couple weeks' time, the 29th is the 1-year milestone. There's going to be an event up at the national park at 3 p.m. and we're going to try to coordinate something up there. So keep that in mind if you guys are in the area. As Dane said, I appreciate your support, and really I don't have a whole lot else to add. Just thank you guys for being here for the ride with us, right? It's some weeks are a little more similar than others, and there's always little gems to find in there as usual, and some weeks it gets really dramatic, and we're here regardless, all the time, sharing it with you guys. And as Dane said, not clickbaity, just giving you guys the straight up information because it's interesting enough as it is. There's no need to add anything or make anything up. It's fascinating. It's more interesting to tell it truthfully, I think. As truthfully as we know how, anyways. Everyone's got their own truth, obviously, so. All right, wrap it up before I get too philosophical here. Mahalo, Dane. Mahalo, everyone. Thank you, guys. Until next week, from hawaiitracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.